Hello and welcome to this ABI Labs video. In the previous video we introduced the RevEng and how this system helps many organizations across the world sustain the life of their critical electronic assets. In this video we will be diving into how this works in more detail. To begin with, I will be giving you an overview of the instrument within the software. Let's dive into how you would generate a netlist for a PCB. This is the RevEng instrument within the System 8 Ultimate software. We have several tabs at the top and they are designed in this way to guide the user through a step-by-step process of acquiring the connections and generating a netlist for a PCB. Under the Start tab we can add a board name, we can add a description, and we can also add an image of the PCB you are working with. The next step is to go into the Setup tab in order to configure the hardware and cables connected to it. Next, we'll look at how you define all of the components present on the PCB. The top section lists all of the cables available as standard in the RevEng library as supported by ABI. The middle section shows the hardware connected to the PC and the number of channels available. As I physically connect the cables to the hardware, I can replicate its position by clicking and dragging to the appropriate location in the instrument itself. I will drag this cable assembly to this first connector, and I will drag this one over here. If you need to create your own custom cable, you can easily add this to the instrument. By clicking on Add New Cable, I can enter the part number, add a description, and click on OK. Now you see this custom cable added to the list. I can simply click on Edit. Within this window I can define the type of clip, the number of pins, and the location on the cable itself. You can also add a picture of the cable. Once you have defined everything, you simply click on Save and Close. Finally, you need to define the power rails on the PCB. Sometimes there can be more than one, so you need to define as appropriate. Now that the hardware and cables are set up, we can move on to the Components tab. In this section, you are required to list out all of the components on the PCB. The reference is important because the software will use it to guide the operator in the clipping and hooking process. So all of the components need to be listed here. I will be adding a number of different components such as an LCD, an IC, a connector, as well as several discrete components. When all the components have been listed, we can move on to the next tab. Now, let's look at the scanning process. This section indicates the scanning progress and guides the user step by step through using the clips, connectors and hooks for the required components on the board. We begin by clicking on Scan Board. We are now presented with the warning. This tells us to make sure no power is being applied to the board and that any capacitors have been discharged. Following this, we are notified to make sure the power monitor channels have been connected. We are now presented with the Scan Component window. In this window, we can see all of the components we listed earlier. We now basically follow what the software is telling us to do. To begin with, I'm going to connect with the LCD, and in order to connect with this, I will need to use hooks since there are 28 different pins. I have already done this to speed up the whole process. And I will show you how this works when I connect to the 5-pin header later on. Now the software is telling me to confirm the clip on U14. It's telling me to use this particular cable and the first clip for that cable. Once I have attached, you will see the colors change to represent a good connection. I will now confirm and move on to the next component. For this particular component, I will need to use hooks. So I will add hooks. I have many different hooks on one of my cables, and in order to make this process easier, I can use a probe to identify which hook I'm going to use. So once I have touched my probe with the hook, we can see it has identified a particular hook. I will simply connect to the header and accept the clip. For my discrete components, I will be using the probe, so I will simply select probe. Now the scanning process is ready to begin. The software is now asking us to probe the different pins on the discrete components. I will use the foot switch to speed up this process. Now we'll be looking at how you can see previously acquired scans and where you can find the netlist within the instrument. Once this process has been completed and all components have been scanned and all connections are learnt, the component coverage will be at 100%. In the next tab, we can see the scan history, and we can also delete or reacquire scans. In the final tab, we can see a list of all the connections between the components we scanned earlier. Once we have reached this stage, we can now export the netlist and import it into Edwin to generate the schematics. Now that the work with RevEng is finished, let's look at the schematic generation software Edwin. To generate the schematic, I'm going to launch Edwin, which is the schematic generation software. I will begin by importing the netlist I created with RevEng. We can see that the project has been successfully imported, so I can close these windows and open up the diagram. To begin with, I'm going to define the size of my page. Now I'm going to define the minimum space required between each component. I will now place all the components outside of the schematic. I'm going to select one component to be used as a reference. I'm going to place all of the remaining components around this device. Now all we need to do is make the connections between each component. Thank you for watching this video.